All right, class, in this video, we're going to continue our series on system of equations. We have already looked at how to solve these systems using the graphing method, and we've also looked at how to consider the actual equations and determine the number of solutions, whether it's one solution, no solution, or infinite solutions. Now I want to give you another method of actually solving for a system of equation, and it is substitution. Now, we've talked about substitution in class. We've actually done a fair amount of substitution, but now we want to apply it to more than one equation. So let's just walk through this first example. We have two equations that we're given, y equals 4x minus 7 and y equals 2x plus 5. And if this system, we want to know, where do they cross? Now again, we could graph both of these. Both of these are written in the form of y equals mx plus b. We could graph them, and we're actually going to see that they would cross at the point 6 and 17. But there's another way of doing this, and it's called substitution. And I want you to think about it. In this first equation, I'm saying that y literally equals 4x minus 7. And so in this system, when I'm given this second equation, we're saying that if y equals that, then I can replace the y in the second equation with the 4x minus 7 from the first equation. Now think about what happens. Where I begin, I have two equations. Well, let's just look at this top equation. I have two unknowns. In the second equation, I have two unknowns. Well, there's not much I can do with that until I put them in a system together and I have two equations with two unknowns. Because by substitution, I want you to look at this equation. Do you see how this part right here used to be y? Y equals 2x plus 5, but through substitution, I've been able to say that because y equals 4x minus 7, I can replace the y with the 4x minus 7. Now, that means if you look at this equation, I have one equation now with just one unknown. And that's really all that's new in this lesson, because from here, we've done a lot of this over the course of the year. I have variables on both sides, I have integers on both sides, and now it's just a matter of solving accordingly. So I'm going to subtract 2x from both sides to cancel out the x on the right side. I'm going to add 7 to both sides to cancel out the 7 on the left. 4x minus 2x gives me 2x. 5 plus 7 gives me 12. Now, to get the x by itself, I divide everything by 2, and I get x equals 6. Now, that's just the first part of my solution. Now I take this 6 and I pick one of these equations, and I replace the x with the 6 because I'm told that x equals 6. So in this equation, I can take the x and substitute a 6 in for that x. 4 times 6 is 24. 24 minus 7 is 17. Now, if you were to graph this, you would see that this system of equations crosses at 6 in the x-axis and 17 in the y. So you really could write it more officially like this. There's your solution. That is the answer to that system. So let's do another practice problem. Okay, so here we have y equals 2x plus 3. Y equals x minus 3. Not exactly sure what I read there. And y equals 2x. So why don't we do it this way? Let's say if y equals 2x, then let's substitute. 2x is equal to x minus 3. I'm going to subtract x from both sides and get x is equal to negative 3. Then I'm going to substitute again and say that y is equal to negative 3. Notice how I subbed that in for this x minus 3. So y is equal to negative 6. So my solution then is negative 3, negative 6. Now it's really easy to make math errors when you're doing this stuff. So why don't we check it? Why don't we take this one? And let's do a little check work here. Y is equal to 2x. So that's going to be a negative 6. I'm going to substitute in for my y, 2. And then for the x, it's a negative 3. And look at that. That does check. So I feel good about this answer. The intersecting point or solution for this system is negative 3, and negative 6. I want you to pause the video and try this practice problem to the right, and then restart it once you've answered it. All right, so hopefully you paused the video. Why don't we substitute 3x in for y? And we'll get 3x is equal to negative 6 plus x. I'm going to subtract x from both sides and get 2x equals negative 6. Divide both sides by 2 and get x equals negative 3. I then take one of these equations. Let's say y is equal to 3 times negative 3. I substituted the negative 3 in for the x, and so that's a negative 9. So my solution then is negative 3, negative 9. But the great thing about these kind of problems is I can check it. So let's check our work. Let's use the other equation. I'm going to plug negative 9 in for y, negative 6 plus a negative 3, and that does check. Negative 6 minus 3 is a negative 9. So I feel good about my answer. You should have calculated negative 3, negative 9 as the solution to that problem. All right, let's look at another example and one more practice problem. This one's a little bit more involved. You'll notice I've got y. I think the easiest way to approach this one, the easiest way to approach this one would be to take, since we have y equals 3x plus 8, we're going to plug it in right there for y. And so let's rewrite this so you can see it. 8x plus 4, you have to use your parentheses here. Remember that when the integer and the variable are kind of butted up to each other, that's multiplication. But as soon as you throw in something like 3x plus 8, then distribution is going to have to take place. And I'll show you that again in a moment. Equals 12. So that's what it looks like. This whole section right there used to be y. But because I know that y equals 3x plus 8 in this system, I can put the 3x plus 8 in for y, but you have to use your parentheses, and here's why. You have to distribute. Remember how I've been telling you that all the stuff we're learning this year in pre-algebra, it never ever leaves? You just have to keep these skills in your tool belt and recognize when they're there. All right, let's keep going. So let's make that a little brighter. 8x plus, I'm going to write all of this out just so that I hope it helps. You could do some of these steps in your head, but we have 4 times 3x and then 4 times 8. So if we were to go one more level, that's going to be 8x plus 12x plus 32 equals 12. Combine like terms, that's 20x plus 32 equals 12. We're going to subtract 32 from both sides. I hope all of this is looking very, very familiar to you. It should. And that's going to give me a negative 20. Divide both sides by 20, and I get x equals negative 1. Now we have to substitute. I think the easiest one would be to substitute into this one to solve for y. So y is equal to 3 times negative 1 plus 8, or y is equal to 5. So my solution then is negative 1 and 5. If I were to graph these two equations, they would cross at the point negative 1 in the x and 5 in the y. Let's check it. Let's use the bottom one. So 8 times negative 1 plus 4 times 5 is equal to 12. So that's going to be negative 8 plus 20 equals 12, and that is true. That's going to work, so I feel good about my solution. All right, so I want you to pause the video and try this practice problem. All right, so let's see how you did. Since we have a y equals something, the easiest way to approach it is to put whatever y equals in for y. So that's going to be 2x plus 5. We're going to open our parentheses, put in 6x minus 4, close parentheses, equals 44, and then going to distribute. So that's going to be 2x plus 30x minus 20 equals 44. So that's going to be 32x is equal to 64. I added 20 to both sides. I'm going to divide both sides by 32 and get x equals 2. All right, let's substitute in and get y is equal to 6 times 2 minus 4. That's going to be 12 minus 4, or 8. So the solution is 2 and 8. If I were to graph These two equations, they should cross at the point 2, 8. 2 in the x, 8 in the y. But let's make sure we check it. I'm going to say 2 times 2. I'm using the first equation, and I'm substituting my solution in for the points x and y. That should be an 8. Equals 44. So 2 times 2 is 4. 8 times 5 is 40. 4 plus 40 does in fact equal 44. So I feel good about my answer. All right, class, this is the method of substitution. This one takes some practice. And so rewatch this video and move through the homework.